Now that this is settled, let me go back to the topic of test data management. I would like to introduce you to the topic today by first giving you a brief overview of how test data management has evolved in the automotive industry over the past, let's say, 20 years, about 20 years. To do that, I switch the presentation. Okay. When we talk about test data management, we first have to clarify what we mean by test data. And you see it here on the one hand, this is all information needed to prepare or to conduct or reconduct or interpret a physical or virtual validation. We call it then a test run. And this so-called metadata information can be very extensive, varied, often interdependent. And you see some examples here. Metadata can be the description of test cases, test procedures, test models, test items, and so on. And on the other hand, you have information which is created during such a test run. We name it then bulk data. This can be, for example, sensor data, bus data, events, image streams, status information, coordinates, also documents like Excel Power with final test reports inside. Yeah, this is all bulk data. And throughout the entire vehicle development process, test data is needed and created in a wide range of test domains. And a test domain validates a certain functional performance or safety-related feature of a vehicle or its components. Here you see some examples of test domains. And in all these different test domains, you will usually find a large number of very specific authoring and automation tools for conducting domain-specific measurements or recordings or simulations or analysis and reporting and so on. And many of these tools come along with their own data management features. Which can be, on the one hand, individual self-developed solutions, often based on file directories and tailored for specific application areas or users, and often also with little metadata management capabilities. Or you can find also in these test domains vendor-specific or tool vendor-specific commercial data management solution, often with proprietary storage formats, tailored also to specific test domains and closely tuned to the specific measurement, simulation, or analysis tools of the vendors. These solutions have mostly grown in the test domains for years and are still widely used in many companies today. However, since many of them are not standardized, they have often limitations on how data can be easily accessed and shared with other tools and teams. And some pioneers from BMW, as far as I know, Daimler, Porsche, I think, recognized this at an early stage and were dealing with these questions you see here already at the end of the 19th. That means they asked themselves, will tool-specific data silos be sufficient in the future? And how must data management evolve to meet the future demands related to the increasing importance of test data, the importance of collaboration, traceability, and last but not least, also the increasing importance of information security. And therefore, they founded the ADAM working group, and started developing the first versions of the other ODS standard. And the idea of ODS was to establish a standard for managing and exchanging test data in the automotive industry. And the plan was to enable or to improve interoperability and efficient data exchange between different testing tools and users. And this led basically to three main specifications. Of course, there are a lot of more, but the main specification are three things. First, a generic data model, so-called base model here on the top you see it, that has enough structure and flexibility to cover the domain-specific requirements for the documentation and storage of test data by customization, and such a customized base model is then called application model. The second main specification is an API that allows different tools to access and interpret the defined application models, and thus also to understand the test data stored. And the third main specification was or is a file format today called ATFX that allows the transport and exchange of both the respective application model and also the exchange of the bulk data of a test run. And over the time, ODS was continuously developed and improved by the ADAM working group, and in addition to the already stated base model, API, and file exchange format, the ODS working group also created recommendations and specifications for managing test data in big data ecosystems, and a specification for directly accessing to test data stored in external file formats. That's very new, this specification. External file format means non-ODS compliant file formats. And additionally, also so-called associate standards were developed over the time, which provide users recommendations and best practices on how to create an application model for a specific test domain or a specific field of application or a specific use case. You see here some examples. This, for example, application models for managing data in the field of NVH, or models for managing bus data and geometry data, data models for the integration of MDF files, data models for managing information related to the instrumentation used for a test run. And currently, the ODS working group plans additionally to develop an associate standard for managing data artifacts coming from the ADAS autonomous driving domain. That's very new, the plan, and we will see what happened there. And in parallel, the tool vendors started to pursue different strategies to adapt the ODS standard in their products. Many tool vendors had decided to just build in functions for importing, exporting ATFX files, while their underlying data storage remained proprietary. Other tool vendors decided to use the entire standard, including the ODS compliant application model, as well as the ODS API as a basis for their data management system. Yeah, and this resulted that you can find today ODS in many vendor products, and of course also enterprise solutions at OEMs and tier one suppliers around the world in a very wide range of different already stated test domains. But despite all of this standardization work and regular cross-testing of different tool vendors and so on, the implementation of ODS-based application that seamlessly integrate tools from different tool vendors in an, let's say, end-to-end tool chain has long remained difficult due to different reasons. And that's why Audi decided more than, I think, 10 years ago to tackle the topic of test data management from a more strategic point of view. The idea of Audi was to take up the ODS approach and to develop a framework with which ODS-based data management solutions for different test domains can be efficiently implemented by reusing, administering, configuring freely available open source software components. And in addition, it should also be ensured that various measurement processing or evaluation tools can be easily integrated with those openMDM-based solutions. And a further key requirement was that the collection, documentation, and management of metadata becomes a central part of the test process, independent of specific measurement and analysis systems. And this then was the birth of the openMDM framework, which was first published by Audi as open source roundabout in 2010, and then later has been continuously developed and maintained as part of the today's Eclipse openMDM working group. Angelika Wittek will later give you a brief overview after my presentation here of what has happened in this working group over the past 12 months and what the current plans are for the near future. As you see here, basically, openMDM today consists of three main components, I would say. First, a 100% ODS compatible metadata model, the openMDM application model, with which both the metadata and the bulk data coming from different measurement simulation systems can be classified and described in terms of content. Second, an API that can be used to read and write the individual data objects of the defined metadata model via one or several ODS server to access the data. And third, openMDM comes along with a web client that provides a variety of configurable functions for navigation, for search, for preview, for selection, and for the exchange of data. And each user company or tool provider can select those components from the framework that are required for the respective implementation requirements. And of course, in some cases, only the data model with or without API is used, and the user interfaces are developed then in-house. You can find this approach, for example, later on the agenda in the product solutions from Siemens and Karakun, or in the application example from BMW in the field of vehicle interior and exterior testing. And in other cases, the complete framework, including the web client, is used, and individually functions are supplemented by, let's say, additional developments of third-party products available on the market. Skoda will present this approach to you later using the example of a solution for managing information coming from a data logger in test vehicles. Okay, additionally to the efficient implementation of ODS-based solution for single test domains, the use of openMDM, of the openMDM framework, enables you also to standardize the navigation across different test domains. In this case, all the users leverage the same functionality or functions and controls to search, find, and use data of a specific test domains or cross test domains. And in doing so, each test domain can manage their own data stores and use their own domain specific metadata structure, and from a comprehensive perspective, the domain-specific data stores are then merged by the openMDM API, acting here called as a data layer into a virtual overall database. And of course, this single data stores or the overall data store can then also be connected to local or central data processing, analysis, evaluation tools based on commercial off-the-shelf products or based on advanced analytics technologies. And of course, for global acting companies, this is also possible across several locations due to the use of web technology. And accordingly, like Skoda is doing it, you will hear it later, the deployment of such openMDM-based solution is more and more shifting from local company internal IT infrastructures towards private or hybrid cloud environments. So I have to look on the time. Sorry, I'm a little bit late. So let's summarize how test management from our point of view has evolved during the last years. I think today most experts agree that self-contained and proprietary or tool-focused solutions for test data management will reach their limit in the long term, and best practices in the past have already proven that using the standard ASAM ODS facilitates interoperability between validation systems coming from different vendors. And many projects have already shown that the openMDM framework and additional on the market available tools help both tool providers and user companies. We have presentation of both here today, help them with the efficient implementation of ODS-based test data management solutions. And finally, I would mention that there are, from our point of view, more and more user companies in the world, like BMW and Skoda, that take a strategic approach for test data management. And for these companies, the openMDM framework is a good foundation or a good basis for implementing a unified cloud-based test data navigation platform across different tools, teams, test domains, and locations. Okay, I'm late. With this conclusion in mind, I will now see, we will now see in the further course of this summit how user companies such as BMW and Skoda, as well as tool providers such as Siemens, Karakun, and Peak Solution, use the openMDM framework and additional components for the implementation of test data management solutions. Okay, does anyone have already questions at this point?